Dear students, today let us see some more problems on quadratic equations. Which was our last problem? In the last class we had solved question number 21. Yes, right. So this problem we had solved it in the last class. Let us look at the next question. Question number 23. If alpha and beta are the roots of the equation 8x square minus 3x plus 27 equal to 0, then the value of alpha square by beta whole power 1 by 3 plus beta square by alpha whole power 1 by 3 is. They have given a quadratic equation which is 8x square minus 3x plus 27 equal to 0. Okay? And we are asked to find out alpha square by beta whole power 1 by 3 plus beta square by alpha whole power 1 by 3. This is what we want to find out. Okay. Given that alpha and beta are the roots of this equation. So first I will find out sum of the roots, alpha plus beta. Alpha plus beta is given by minus b by a. So in this case we get 3 by 8. Then product of the roots, alpha into beta, that is equal to c by a. So that will give you 27 by 8. Then we want to find the value of this, alpha square by beta whole power 1 by 3. I will write this as alpha power 2 by 3. Alpha square whole power 1 by 3 equals alpha power 2 by 3 divided by beta to the power 1 by 3 plus beta square power 1 by 3, that is beta to the power 2 by 3 divided by alpha power 1 by 3. That's equal. Now I take LCM. LCM is beta power 1 by 3 into alpha power 1 by 3. Together I write it as alpha beta to the power 1 by 3. Numerator will be alpha power 2 by 3 into alpha power 1 by 3, which is equal to alpha. Alpha power 2 by 3 plus 1 by 3 we get, which is 3 by 3, that's 1. Plus beta power 2 by 3 into beta power 1 by 3, that is equal to beta. Then that's equal to alpha plus beta, we already know, 3 by 8 divided alpha beta to the power 1 by 3. Alpha beta is 27 by 8 to the power 1 by 3. Okay, 3 by 8 I will write as this, and 27 by 8 to the power 1 by 3, which means we are finding the cube root of 27 by 8. 27 can be written as 3 cube and 8 can be written as 2 cube. 3 cube by 2 cube whole power 1 by 3, that is nothing but 3 by 2. 3 gets cancelled, 2 1s are 2 4s are. So the answer is 1 by 4. 1 by 4, which is the second option. Okay, then look at question number 24. If alpha and beta are the roots of ax square minus 2bx plus c equal to 0, then alpha cube beta cube plus alpha square beta cube plus alpha cube beta square is equal to. The given equation is ax square minus 2bx plus c is equal to 0. Alpha and beta are the roots of this quadratic equation. So alpha plus beta, sum of the roots, is equal to 2b by a. And product of the roots, alpha into beta is equal to c by a. Okay? Alpha plus beta is equal to minus b by a. That is a general formula. If you have ax square plus bx plus c equals 0, now we have ax square minus 2bx. So in place of b we have minus 2b now. So alpha plus beta is 2b by a and alpha beta is c by a. Then what do we want? We want alpha cube beta cube plus alpha square beta cube plus alpha cube beta square. This is what we want. Now I will take alpha square beta square as a common factor here. From these three terms, I will take alpha square beta square as a common factor. Then what will remain here? If I take alpha square beta square out of this, here alpha beta will remain. Plus here alpha square beta square I have taken out, so beta will remain. Plus from this, since I have taken alpha square beta square out, alpha will remain. Okay? So we have alpha square beta square into alpha beta plus beta plus alpha. Alpha square beta square we can write it as alpha beta whole square into alpha beta plus beta plus alpha can also be written as alpha plus beta. Okay, alpha beta that is nothing but c by a whole square, c square by s into alpha beta c by a plus alpha plus beta 2b by a. So there is a same denominator a, I just need to add the numerator c plus 2b. So c square into c plus 2b by a here into a square, so it will be a cube. So this we can write as c square by a cube into c plus 2b. C square by a cube into c plus 2b. Look at this first option. C square by a cube into c plus 2b. Okay, then let's have a look at the next question. If alpha and beta are the roots of x square minus x plus 2 equal to 0, then alpha cube beta plus alpha beta cube is equal to. Okay. Given that alpha and beta are the roots of x square minus x plus 2 is equal to 0. Alpha and beta are the roots of this. So sum of the roots alpha beta plus beta is equal to minus b by a. That will give you 1. Product of the roots alpha into beta is equal to c by a. That will give you 2. Then we want alpha cube beta plus alpha beta cube. This is what we have to find out. Now from these two, I can take alpha beta as a common factor. If I take alpha beta as a common factor, then here we have alpha square and here we have beta square. Okay, that's equal to alpha beta into alpha square plus beta square. We got alpha beta into alpha square plus beta square. I can write it as alpha plus beta whole square minus 2 alpha beta. Alpha plus beta whole square minus 2 alpha beta. Because if I expand it, I am going to get alpha square plus beta square plus 2 alpha beta. Minus 2 alpha beta is there, so that gets cancelled. We get back to alpha square plus beta square. So why I am writing like this? Because we know alpha plus beta and we also know alpha beta. Okay. Then now we substitute. What is alpha beta? Alpha beta is equal to 2 into alpha plus beta is 1. So 1 square minus 2 into alpha beta, which is 2. So we get 2 into minus 3, that's equal to minus 6. So 1 minus 4 minus 3, 2 into minus 3 will give you minus 6. The first option. Okay. Next. 27th question. The difference between the corresponding roots of the equations x square plus ax plus b equal to 0 and x square plus bx plus a equal to 0 is same. Then what happens? Difference between the corresponding roots of these two equations. Okay, difference between the roots, there is nothing but alpha minus beta, or I would say modulus of alpha minus beta. If alpha and beta are the roots, then modulus of alpha minus beta will give you the difference between those two roots. This is obtained as square root of alpha plus beta whole square minus 4 alpha beta. Because alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta minus 4 alpha beta we have. So plus 2 alpha beta minus 4 alpha beta, you will get minus 2 alpha beta. Alpha square plus beta square minus 2 alpha beta, that's nothing but alpha minus beta whole square. Root of that will give you modulus of alpha minus beta. Okay. See, in this question what they have given is difference between the roots. So this first equation has 2 roots. So take the difference of those 2 roots and look at this equation. This is the second equation. This equation also has 2 roots. Take the difference between these two, the two roots of this equation. The difference between the roots of this equation is same as the difference between the roots of this equation. For the first equation, I will take alpha 1 and beta 1 as the roots. For the second equation, I will take alpha 2 and beta 2 as the roots. Then what they have given is alpha 1 minus beta 1 is equal to alpha 2 minus beta 2. This is what they have given. But we don't know whether which is greater, alpha 1 is greater or beta 1 is greater, we don't know. So what I will do is I will take modulus. Okay. So these two are equal, that is what they have said. I am taking the roots of this equation as alpha 1 beta 1 and the roots of the second equation as alpha 2 and beta 2. then difference between the corresponding roots. That means alpha 1 minus beta 1 is equal to alpha 2 minus beta 2. Their difference means greater minus least. I don't know which is greater, whether alpha 1 is greater, beta 1 is greater, or alpha 2 is greater, or beta 2 is greater. We don't know. So we take the modulus. Okay. Now, according to this formula, this can be written as root of alpha 1 plus beta 1 whole square minus 4 alpha 1 beta 1. That's equal to square root of alpha 2 plus beta 2 whole square minus 4 alpha 2 beta 2. Okay. Substitute now. Alpha 1 plus beta 1. I have taken alpha 1 and beta 1 as the roots of this equation. So sum of the roots alpha 1 plus beta 1 is equal to minus a root of minus a whole square minus 4 into alpha 1 beta 1 product of the roots c by a, or in this case b by 1, which is b. That's equal to root of alpha 2 plus beta 2, sum of the roots. Alpha 2 and beta 2 are the roots of this equation. Sum of the roots minus b by a, in this case minus b whole square minus 4 into alpha 2 beta 2 product of the roots c by a, in this case b by 1, which is b. Okay. So this will be minus a whole square, that is a square. A square minus 4b is equal to root of b square minus 4a. I'll square this equation. Squaring this, you get a square minus 4b is equal to d square minus 4a. So here we want to establish a relation. Look at what we want. We want to find a relation between a and b. Right? So now I will bring d square to LHS and take this minus 4b to RHS. So that will give you a square minus b square is equal to 4b minus 4a. Take minus 4 as common. Minus 4 into a minus 4. Okay? Now a square minus b square can be written as a plus b into a minus b. A plus b into a minus b is equal to minus 4 into a minus b. We can cancel that a minus b. Then we get a plus b is equal to minus 4, or a plus b plus 4 equal to 0. We can cancel a minus b because a minus b cannot be equal to 0, because if a minus b is equal to 0, then a is equal to b. Then that means we are talking about two same equations, which cannot happen. So I can cancel a minus b. Hence we get a plus b minus b is equal to minus 4. Hence a plus b plus 4 equal to 0. Third option. Next, if the roots of the quadratic equation x square minus 4x minus log a to the base 3 is equal to 0 are real, then the least value of a. The roots of this equation are real. Roots are real means there arises two cases, either real and distinct or real and equal. The quadratic equation is x square minus 4x minus log a to the base 3 is equal to 0. Right? Roots are real. Roots are real means either real and distinct or real and equal. So when the roots are real, then what happens to delta? Delta, the discriminant, is equal to 0 when the roots are real and equal. And delta is greater than 0 if the roots are real and distinct. Now we don't know whether the roots are real and distinct or the roots are real and equal. The only thing what they have given is that the roots are real. So roots are real means either the delta is greater than 0, that is when they are real and distinct, or delta is equal to 0 when the roots are real and equal. So what I do is I will consider both the cases, delta greater than or equal to 0 I will take. Okay, now delta greater than or equal to 0. So that means b square minus 4ac is greater than or equal to 0, or b square is greater than or equal to 4ac. Now coming to this equation, here a is 1, b is minus 4 and c is minus log a to the base 3. b square minus 4 whole square 16. That is greater than or equal to 4ac, 4 into a, that is 1, into minus log a to the base 3. Okay? I will divide by minus 4. When I divide by minus 4, inequality gets reversed. whenever you divide or multiply an inequality by a negative sign, inequality gets reversed. So you will get minus 4 less than or equal to log a to the base 3. Or I can write log a to the base 3 is greater than or equal to minus 4. Right? Which implies a is always greater than or equal to 3 power minus 4. 3 power minus 4 is nothing but 1 by 3 power 4, which is 1 by 81. By definition, you know, log b to the base a is equal to x implies a raised to x is equal to b. So if log b to the base a is greater than or equal to x, then a raised a is greater than or equal to 3 power minus 4 here. Right? So a is greater than or equal to 3 power minus 4, that means a is greater than or equal to 1 by 81. 1 by 81. That means the minimum is always greater than or equal to 1 by 81, which means the minimum value of a is 1 by 81. That means the least value of a is 1 by 81. Okay. Let's have a look at this equation. This question now. If the sum of the roots of this equation is 6, then what is the value of k? Sum of the roots of this equation. Okay. So let me write that equation. 5x square minus 4x plus 2 plus k into 4x square minus 2x minus 1 is equal to 0. Now I would like to write in our standard form. Standard form means ax square plus bx plus c. I will group the terms containing x square together. I can write this as 5 plus 4k into x square. I am taking k inside, so I will go 4k x square. After that I am taking x square as common. Here 5 will remain, there 4k. Then plus, similarly x term if I group, here we have minus 4, here minus 2k. Minus 4 minus 2k into x plus 2 minus k is equal to 0. Now here 2, here minus 1 is there, k into minus 1 and minus. So now it is on the form ax square plus bx plus c is equal to 0. Okay, so we have brought it to the form ax square plus bx plus c equal to 0. Now what they have given? Sum of the roots is equal to 6. So alpha plus beta, if I take alpha and beta as the roots of this equation, sum of those two roots is equal to 6 there. Sum of the roots, we know the formula minus b by a. Here b is minus 4 minus 2k, so minus b means 4 plus 2k divided by a is 5 plus 4k. That is equal to 6. Cross multiply. 4 plus 2k is equal to 30 plus 24k. Hence 22k is equal to minus 26. So k is equal to minus 13 by 11. Minus 13 by 11, which is the fourth option. Okay? Then next question. If the product of the roots of the equation 5x square minus 4x plus 2 plus k into 4x square minus 2x minus 1 equal to 0. Okay, same as this equation is 2. See, look at the previous problem. There, sorry, that's the next problem. Previous problem. Here they had given the same equation and given that sum of the roots is 6. Now look at this question. Here they have given the same equation and given that product of the roots is 2. So till here, same thing. You bring in a standard form ax square plus bx plus c equal to 0. After that, product of the roots is alpha into beta, that is equal to how much they have given? 2. Alpha beta is 2. C by a is equal to 2. C 2 minus k by a 5 plus 4k, that's equal to 2. So 2 minus k is equal to 10 plus 8k. So you get 9k is equal to minus 8, k is equal to minus 8 by 9. Minus 8 by 9, which is the first option. Okay. After that, look at question 32. If one root of px square minus 14x plus is 6 times the other, then p is equal. Okay? So one equation there will be one quadratic equation, px square minus 14x plus 8 is equal to 0. One the root of this is 6 times the other. So if I take alpha as one root, the other root I will take it as 6 alpha. One root is 6 times the other. So first root I will take it as alpha, then the second root must be 6 times the other. So I will take 6 into alpha. Okay? So you can take it as alpha and alpha by 6 also, because then alpha will be 6 times alpha by 6. But anyway, this is better. Alpha and 6 alpha I will take. Okay. Then what is the value of p there? First I will go for sum of the roots. Sum of the roots. Alpha plus 6 alpha is equal to how much? Minus p by a. Can I give you 14 by p. So 7 alpha is equal to 14 by p. That means alpha is equal to 2 by p. Then product of the roots, alpha into beta, in this case alpha into 6 alpha, is equal to c by a, that is 8 by p. So 6 alpha square is equal to 8 by p, or 3 alpha square is equal to 4 by p. Now alpha is 2 by p from this equation, that I will substitute there. 3 into 2 by p whole square is equal to 4 by p. 2 square is 4, 4 into 3 is 12. 12 divided by p square is equal to 4 by p. Here p gets cancelled. 4 1s are 4 3s are. You get 3 by p is equal to 1, which implies p is equal to 3. First option. Then 33rd question. Square root of 42 plus root of 42 plus root of 42 plus root of 42, etc. till infinity is equal to how much? Okay. So I will take it as x. Let x is equal to square root of 42 plus root of 42 plus root of 42 plus root of 42, etc. till infinity. Okay. Now, there are infinitely many square roots and there are infinitely many 42s. Among them, if I remove one of those square roots and one of those 42s, still we will be left with infinitely many roots and infinitely many 42s. So, remaining things, okay, apart from this, if I can start from here only, still there are infinitely many roots and infinitely many 42s. So, together I can write that as x. So, x can be written as square root of 42 plus x. Okay. Now you square this equation. If I square this, I get x square is equal to 42 plus x. So x square minus x minus 42 equal to 0. Factorize this, you will get x minus 7 into x plus 6 is equal to 0, which implies either x equal to 7 or x equal to minus 6. Now look at the options. So first option is 7 and second option is minus 6. Which one should we write? We must write 7, because what you are finding here, root of 42 plus root of 42 plus root of 42, etc., it must be positive number. Cannot be negative. Root of 42. So as you know, root of 36 is 6 and root 49 is 9. Root of 42 plus something. So this itself, if you have only root 42, then that will give you 6 point something. So it cannot be negative, right? It has to be positive only. So x must be equal to 7 and not minus 6. So first option is the right answer. Okay, then the 34th question. If 9 power x minus 4 into 3 power x plus 2 plus 3 power 5 is equal to 0, then the solution pair is, solution pair means it's not the ordered pair now. So there are two solutions for this, just like for any quadratic. So what are those two solutions they are asking? Okay. So you can go for trial and error also, putting some value for x and verifying which satisfies or not. That can also be done. I'll go by the actual method. The equation is 9 power x minus 4 into 3 power x plus 2 plus 3 power 5 is equal to 0. 9 I will write as 3 square. So 3 square whole power x, you can write that as 3 power x whole square. minus 4 into 3 power x into 3 square plus 3 power 5 is equal to 0. 3 power x plus 2 I am writing as 3 power x into 3 square. Okay. So 3 power x whole square. 3 square is 9, 9 into 4 is 36 into 3 power x. 3 power 5 is how much? 243 is equal to 0. 3 power 4 is 81, 81 into 3, 243. Okay. For our convenience, I will take 3 power x is equal to t. Let 3 power x is equal to t, then this equation will become t square minus 3060 plus 243 is equal to 0. Okay? Now this is very easy to simplify. We have factorize this quadratic equation. Right? So let us factorize. When we multiply, we should get 243 and when we add, we should get minus 36. 243. 81 into 3, that is not here. Then 27 into 9. Yes. 27 into 10 is 270 minus 27 will give you 243, right? 27 into 9 and sum 27 and 9 that is also 36. So I can write this as t square minus 2070 minus 9t plus 243 is equal to c. Okay. So t, if I take common, t into t minus 27 minus 9 into t minus 27 is equal to 0. So this will give you t minus 9 into t minus 27 equal to 0, which will imply either t is equal to 9 or t is equal to 27. What is t that you write here? We are not asked to find out what is t, we are asked to find out what is the value of x here. So 3 power x is equal to 9 or 3 power x is equal to 27, which implies that either x equal to 2 or x equal to 3. 2 or 3 or 2, 3, second option. That's the answer. This is one way of solving this problem. There is another method also, trial and error. Directly you substitute values for x. So among them, which is easy to substitute? 1 is easy to substitute, I mean easy to simplify, right? So I will put x equal to 1. If I put x equal to 1 and see whether it satisfies. If I substitute x as 1, then this will be 9 minus, here 1 plus 2 is 3, 3 cubed is 27, 27 into 4, 81, plus 3 power 5 is 240. This sum is equal to 0? No. So 1 is not a solution. 1 is not a solution means so this is not the answer and this is not the answer. Okay? Because those two contain 1. The answer is either the second option or the third option. Now don't put x equal to 2, because by putting x equal to 2 you don't achieve anything, because 2 is present in both the options. Either you have to put x equal to 3 or put x equal to 4. I prefer 3. You should simplify. Put x equal to 3. So 9 cube you get. What is 9 cube? 729. 9 into 9 is 81. 81 into 9. 9 ones are 9 and 9 8s are 72. 729. Sorry, not 723, 729. Minus, putting x equal to 3. 3 power 3 plus 2, 3 power 5. 3 power 5 is how much? 243. Right? Plus 243. 3 power 5 is equal to 0. Okay, is equal to 0 or not? That very fine. So 729 minus 4 into 243. 4 3s are 12, 4 4s are 16, plus 1 17, 8 plus 1 9, 72 plus 243. Add these two, we will get 972. 729 plus, yes, 729 plus 243 will be 972 minus 972. This is equal to 0. So when I put x equal to 3, it satisfies answer 2 and 3. 2, 3, that is second option is the answer. Okay, this is another way of solving this problem. Okay, then if x square plus 4ax plus 3 is equal to 0 and 2x square plus 3ax minus 9 equal to 0 have a common root, then a is equal to. They have a common root. I mean, for these two equations, one of them is common, one root is common. Then what happens? What is the value of a? That's what they are asking. So let us just recall that condition. Let me consider two equations. equations a1x square plus b1x plus c1 is equal to 0 is one equation. a2x square plus b2x plus c2 is equal to 0 is another quadratic equation. Okay. If these two equations have a root common, if they have one root in common, then what is the condition? c1a2 minus c2a1 whole square is equal to a1b2 minus a2b1 into b1c2 minus b2c1. This formula you remember. c1a2 minus c2a1 whole square is equal to a1b2 minus a2b1 into b1c2 minus b2c1. Okay, now look at that equation. X square plus 4x 4ax plus 3 is equal to 0 and 2x square plus 3ax minus 9 is equal to 0. Okay, now let us use this formula. C1a2 3 into 2 6 minus C2a1 minus 9 into 1 minus 9 minus of minus 9 is plus 9 whole square is equal to a1 b2 1 into 3a minus a2 b1 4a into 2 that is 8a into b1 c2 4a into minus 9 that is minus 36a b2 c1 3a into 3 minus b2 c1 that is minus 9a. Okay, this will give you 9 6 plus 9 15 square is 225. That's equal to minus 5a into minus 36 minus 9 minus 45a. Okay, so we get 225 is equal to minus 5 into minus 45. 45 5s are 225. So you get plus 225 into a square, which will give you a square is equal to 1. That implies that a is equal to plus or minus 1. Plus or minus 1. Fourth option is the right answer. Okay. Let us look at this equation, this problem. The quadratic equations x square minus 6x plus a is equal to 0 and x square minus cx plus 6 equal to 0 have one root common. The other roots of the first and second equations are integers in the ratio 4:3. Then the common root is okay. So you understand the question first. Two equations they have given. First equation is x square minus 6x plus a is equal to 0. And the second equation is x square minus cx plus 6 equal to 0. These two equations have one root in common. And the other roots of the first and second equations are integers which are in the ratio 4:3. Then the common root is, okay, again one root is common, so we have to use this formula which I will use it afterwards. First I will say let the roots of the first equation be alpha and beta. Alpha and beta are the roots of the first equation. Then I take beta and gamma as the roots of the second equation. I took beta and gamma as the roots of the second equation because one root is common and let that be beta. Okay? First equation has two roots. I have taken them as alpha and beta. Second equation also has two roots and one root is common to the root of the first equation. So I have taken beta and gamma. Okay. Now what they have given is the other root of the first and second. One root is common. Other root of the first and second equations are integers which are in the ratio 4:3. So that means alpha is to gamma is equal to 4:3, or I can write alpha by gamma is equal to 4/3, or gamma is equal to 3 alpha by 4. We can write gamma is equal to 3 alpha by 4. Okay. So now looking at this equation, tell me what is alpha plus beta. Sum of the roots. For the first equation, sum of the roots is equal to 6. And product of the roots, alpha beta, is equal to c by a, which is a by 1, that is a. Then for the second equation, sum of the roots is beta plus gamma. beta plus gamma is equal to sum of the roots is equal to c, and product of the roots beta into gamma is equal to c by a, which is 6 by 1, that is equal to 6. Okay, now here look at this equation. We have beta into gamma equal to 6. From this equation, in place of gamma, I substitute 3 alpha by 4. So beta into 3 alpha by 4 is equal to 6. Right? So then alpha beta is equal to 4 into 6 is 24 by 3. That is equal to 8. Alpha beta is equal to 8. Alpha beta, look at this equation. Alpha beta is equal to 8. So that will give you A is equal to 8. A is equal to 8 we got. So the first equation will become x square minus 6x plus 8 is equal to 0. In place of A, I am writing 8. Okay. So x square minus 6x plus 8 is equal to 0 means its roots are 2 and 4. On factorization you will get x minus 2 into x minus 4 equal to 0. 2 and 4. But we don't know whether alpha is 2 or beta is 2. Okay. So and options also both are there. 2 is there, 4 is also there. Okay. Now I will make use of this formula. The first equation now it has become A is 8. So it has become x square minus 6x plus 8 is equal to 0. Now let us say if I use this formula, what happens? Let us observe. Okay. C1A2 is 8 minus C2A1 is 6 whole square is equal to A1B2 is minus A2B1 minus A2B1 is minus 6 minus 1 minus 6 it will become plus 6 into B1C2 minus 6 into 6 that is minus 36 minus B2C1 minus 8C minus 1 minus 8C is 8C. 8 minus 6 is 2 square is 4 is equal to minus C plus 6 into 8C minus 36. Okay, let us simplify. 4 is equal to minus 8C square plus 36C plus 48C minus 260. Let me simplify. I don't have enough space here. Okay, this. Now take all of them to LHS. We get 8C square, 36 plus 48, 84. So minus 84C plus 220 equal to 0. And divide this equation by 4. So that will give you 2C square minus 21C plus 55 is equal to 0. Now factorize it. 55 into 210. When I multiply, I should get 110C square. When I add, I should get minus 21C. So 10 and 11 is equal. 2C square minus 10C minus 11C plus 55 is equal to 0. 2C into C minus 5 minus 11 into C minus 5 is equal to 0. That will give you either C is equal to 5 or C is equal to 11 by 2. Okay. So C must be equal to 5 only, cannot be 11 by 2, because if I put C as 11 by 2, then we will get the roots as non-integers. But given that the other two roots are integers, so C must be equal to 5. So C is equal to 5. If I substitute here, I am getting x square minus 5x plus 6 equal to 0. The roots of this are 2 and 3. So first equation has 2 and 4 as the roots, and the second equation has 2 and 3 as the roots. Right? Therefore, what is the common root? 2 is the common. Okay? Let's go to the next question. 48. The value of lambda in order that these two equations have a common root. Okay. Again, I can use the same formula. That is why I have written this formula. these two equations have a common root. Let me write those two equations. 2x square plus 5 lambda x plus 2 is equal to 0. That is first equation. Second equation is 4x square plus 8 lambda x plus 3 is equal to 0. These two, they have a common root. I'll use this formula. C1 A2, 2 into 4, 8, minus C2 A1, 6, whole square is equal to A1 B2, 2 into 8 lambda, that is 16 lambda, minus A2 B1, 5 lambda into 4, 20 lambda, into B1 C2, 5 lambda into 3, 15 lambda, minus B2 C1, 8 lambda into 2, 16 lambda. Okay, B1 C2 minus B2 C1. This is 2 square 4 minus 4 lambda here and minus lambda. 4 gets cancelled, you get lambda square equal to 1. Therefore, lambda is equal to plus or minus 1. Okay, look at the next question. 43. If alpha and beta are the roots of 9x square plus 6x plus 1 is equal to 0, then the equation with the roots are 1 by alpha and 1 by beta. So alpha and beta are the roots of the given equation. We want a quadratic equation whose roots are 1 by alpha and 1 by beta. So what to do? Change x to 1 by x. Here the given equation is 9x square plus 6x plus 1 is equal to 0. Replace x by 1 by x. So this will become 9 by x square plus 6 by x plus 1 is equal to 0. Okay. Now multiply this equation by x square, that will give you 9 plus 6x plus x square is equal to 0. In other words, x square plus 6x plus 9 equal to 0. Third option. Then 47th question. If 2 plus I root 3 is a root of x square plus px plus q equal to 0, then what are p and q? So the quadratic equation is x square plus px plus q is equal to 0. 2 plus I root 3 is a root. If 2 plus I root 3 is a root, then 2 minus I root 3, its conjugate, is also a root. I will go for sum of the roots. Sum of the roots, add these two, you get 4. From this equation, sum of the roots is minus b by a, so that is equal to minus p. Which means p is equal to minus 4. P is minus 4 in two options is there. So you have to find out q also. I'll go for product of the roots. Product of the roots is 4 plus 3, which is 7. So here what you get, the product of the roots is q. Q is equal to 7. P is minus 4, q is 7, fourth option. Then 49th question. If a and b, here there is a correction, make it as alpha and beta. It's not a and b, it should be alpha and beta. If alpha and beta are the roots of x square minus px plus q is equal to 0, x square minus px plus q is equal to 0, then we want alpha square plus beta square divided by alpha power minus 2 plus beta power. It's not visible properly. It is alpha power minus 2 plus beta power minus 2. That should be equal to what they are asking. So this is equal to alpha square plus beta square divided by, I write this as 1 by alpha square plus 1 by beta square. 1 by alpha square plus 1 by beta square. On simplification, alpha square plus beta square divided by, take LCM here, beta square plus alpha square divided by alpha square beta square. These two, alpha square plus beta square, gets cancelled. This will come up to the numerator. So alpha square beta square. In other words, alpha beta whole square. Alpha beta is nothing but c by a. So q by 1, which is q. So answer is q square, fourth option. Then 50th question. If alpha and beta, again here also it is printed as a and b, you should write that as alpha and beta. If alpha and beta are roots of ax square plus bx plus c is equal to 0, then what is alpha by beta minus beta by alpha whole square is ax square plus bx plus c is equal to 0. This is the given quadratic equation. We want the value of alpha by beta minus beta beta by alpha whole square. Let us simplify this. Alpha square minus beta square divided by alpha beta whole square. Okay, taking LCM. Alpha square minus beta square, I will write it as alpha plus beta into alpha minus beta divided by alpha beta whole square. Alpha plus beta is sum of the roots, which is given as minus b by a, and alpha beta is the product of the roots, that is equal to c by a. Alpha minus beta can be written as square root of alpha plus beta whole square minus 4 alpha beta whole square. You know this formula, I explained it in an earlier problem. Alpha minus beta can be written as root of alpha plus beta whole square minus 4 alpha beta. Here a gets cancelled. So you get, I'll continue here, minus b by c into root of, see, alpha plus beta is minus b by a. Minus b by a whole square is there. So I directly write b square by a square. Minus 4 alpha beta is c by a. So minus 4 c by a whole square. So this is equal to, here minus b by c whole square, that will become b square by c square into b square by a square minus 4 c by a. Take LCM here, a square is the LCM, that will give you b square by c square into a square is the LCM, divided by a square minus 4ac. That's equal to b square into b square minus 4ac divided by c square a square. Okay, which is the first option. Then look at question number 52. If alpha and beta are the roots of x square minus ax plus b square is equal to 0, then what is alpha square plus beta square they are asking. Okay, equation is x square minus ax plus b square equal to 0. Alpha plus beta is equal to a, alpha beta is equal to b square. Sum of the roots is minus b by a, here it is a. Product of the roots is c by a, which is b square. Alpha plus beta is equal to a, alpha beta is equal to b square. We are asked to find out alpha square plus beta square, that can be written as alpha plus beta whole square minus 2 alpha beta. Alpha plus beta is a minus 2 into alpha beta b square. Answer is a square minus 2b square, which is the first option. Sorry. First option, right? Then, last question, 53rd question. If alpha and beta are the roots of the equation x square plus x plus 1 is equal to 0, x square plus x plus 1 is equal to 0, then what is alpha square plus beta square they are asking. Alpha plus beta is equal to minus 1, alpha beta is equal to 1. We want alpha square plus beta square. I can write this as alpha plus beta whole square minus 2 alpha beta. Alpha plus beta is minus 1, whole square is 1, minus 2 into alpha beta. So answer is minus 1. This is one way of solving this problem. There is another way also. Say x square plus x plus 1 is equal to 0. The roots of this quadratic equation are omega and omega square. Okay, omega and omega square. So I can take alpha as omega and beta as omega square. Then we want omega square plus omega square whole square, that is omega power 4. That's equal to omega square plus omega power 4 can be written as omega. Okay, so omega plus omega square is nothing but minus 1. In this way also we can solve this problem. Okay students, with this we have come to the end of this chapter. Okay, in between I have left so many problems, that is for you to solve, that is homework. Solve all those problems, verify your answers. If you have any difficulties in solving them, you please ask those questions in our WhatsApp group. Thank you.